Hi, this is Mr. Ward, and I'm doing a video key for Do Now 14.3. So that'll be the key. All right, so if we're flipping a coin over and over again, is that a repetitive event where each event is independent of the last? Ooh, there's a typo, I'll fix that. Or where each event is independent of the past? Well, in fact, yes, it's a repetitive event because if you flip a coin and then you flip another coin, the new flip doesn't have anything to do with the last flip. So we would consider that repetitive, not a non-repetitive event. Okay, so if it were a non-repetitive event, the previous event would have had to affect the new event. So when we have just repetitive events, if I have 3 repetitive events, I take the probability of one event and I multiply it times itself and then times itself again. So I'm just going to raise that probability to the third power. So if I'm flipping a coin, that's a 1 in 2 chance of getting heads. And if I flip it 3 times, then I'm going to say 1 in 2 times 1 in 2 times 1 in 2, which will be 1 in 2 to the third power, or 1 over 8. So there's a 1 in 8 chance of getting heads 3 times in a row. Okay, if I'm pulling 3 cards from a deck of cards and I'm not replacing them, would the pulls be repetitive, independent from each other, or not repetitive, where each new event has affected the last one? Well, I've certainly affected the last event, because if I pull 1 card from my 52-card deck and I don't put it back in, now I have 51 cards. And so I have changed the number of possible outcomes. So if I wanted a King of Hearts on the first pull, and I didn't get it on the first pull, on the second pull, instead of a 1 in 52 chance, now I have a 1 in 51 chance. If I don't get it on the second pull, then on the third one, now I've got 50 cards and a 1 in 50 chance. So that is a non-repetitive, dependent type of event. All right, so let's say we have the letters of the alphabet randomly organized, and we have selected the letters C, A, T. And so we want to figure out how many different ways could we select the letters C, A, and T from that randomly organized alphabet if the result had to say C, A, T. So what I've implied here is an order. So we have to pick C first, then A second, and then T third. Well, there's only one C in the alphabet. There's only one A in the alphabet and only one T in the alphabet. So really, there's only one way that this can happen. I have to pull C first, then I have to pull A second, then I have to pull T third. If I want the probability, then I've got to divide that 1 by all the different ways that I could pull from that alphabet, which would be 26 ways, then 25 ways, then 24 ways. So it would be 1 out of 26 times 25 times 24 ways. So probability is always the desired outcome divided by all the possible outcomes. So this reason we keep focusing on counting and how many different ways things could happen is we're going to need to know how many different ways a desired outcome could happen, and we need to know how many different ways outcomes could happen, so all the possible outcomes. Now let's consider that last situation. How many different ways could you have picked the letters C, A, and T from that randomly organized alphabet if you didn't need it to spell anything in particular? So what I'm saying here is there's no order. It could be CAT or CTA, et cetera, et cetera. So what you want to think about is how many different ways could I organize that? So I could have first pulled a C or an A or a T, right? That's the first thing I could have pulled. There's 3 different ways I could have done the first pull, okay? There's 3 different possibilities. Once I've pulled a C, then I only have an A or a T that I could pull. Once I've pulled an A, I've only got a C or a T that I could have pulled. And once I pulled a T, there's only an A and a C. And these are only the desired outcomes, by the way, because there's, of course, all the other letters. And once I pulled an A, so I pulled a C and then an A. So first, here's 3 possibilities. And then for each of those 3 possibilities, there's 2 possibilities, okay? And then once I have pulled any one of these, so here's the path I took, C, then A, then all I've got left is T, So there's just one possibility now. If I had pulled C, then T, then all I've got left is A. So now there's just one possibility. So we end up with 3 possibilities times 2 possibilities times 1 possibility. Okay, so all I have left is a T after this path. So I pulled an A, then a C, then a T. I pulled an A, then a T, then a C. Once again, I'm down to just one possibility after I pulled the T. So there were 3 possibilities in the first run, 2 possibilities after that, and then just a C or an A. So in each event, so the first event we had 3 possible outcomes since we didn't care which letter came first. Then the second event we had 2 possible outcomes because we did not care about which order it came in. But there are only 2 left if we pick the one of our 3. And then finally, there's just 1 left. So it's 3 times 2 times 1, which is 6. And of course, the fancy way to write that is 3 factorial. Okay, so when we have 3 possibilities and 3 things, and we could put them in any order we want, then there are 3 factorial ways we could arrange it. So 3 factorial. I'm going to stop.